All right, guys, gals, Joe, and everybody else, welcome to video lesson 5-3, our lesson on solving trigonometric equations. Here we go, here we go, here we go. Okay, these are tips to solving trigonometric equations. Notice that again, they're tips. There is no recipe, there's no one way, there's no best way. Sometimes of solving these things, you basically, the one that's the only really method is solve for the trig function. Get the trig function by itself. Okay, you got to be good with algebra in order to do this. These are now, just some of the ideas that you may have. Number one, use identities to simplify or write as one function, look to factor, and use the quadratic equation if necessary. We will also be talking about different types of solutions. There's two major types, the periodic solution and the general solution, and you'll find out what that means in 1 second. Also, just beware, sometimes algebraically you're going to get an answer, but when you go back to plug it back in, it does not work. You need to throw that answer out, and that, of course, would be called what we call an extraneous solution, one that you throw out because it doesn't work. Okay, let's just talk about sine x is equal to 1/2. You see in blue here there is a sine curve. Okay, several periods of it. You see a dotted line. That is when sine is equal to 1/2. We already know a whole bunch of answers. In degrees, we already know that this point and this point both work. It's where the sine curve meets the y equals 1/2 curve. Okay, and I'm hoping you guys know that this angle here is 30. This angle here would be the second quadrant, which is 150. And also now you know once you go through, we go through one complete period right here. As we go back into the first quadrant, as we loop around the unit circle a second time, I'm going to have another answer, which is 390. I'm going to have another answer, which is going to, in the second quadrant now, which is going to be 510. And eventually, if I looped far enough around, I would have more answers as I went further and further down the right-hand side. Also, don't forget now, I'm going to have answers as I move to the left on the left-hand side too. Like, for example, this one would be negative 210. And going to the left, I would have another one at negative 330. There are, in essence, an infinite number of answers. It's basically any 30-degree angle in the first or second quadrant, no matter how many times around we go around the unit circle. The periodic solution to this, typically we do this 0 to 2 pi, or in degrees 0 to 360. The periodic solution in degrees, we already said, is 30 and 150. In radians, of course, that would be pi over 6 and 5 pi over 6. But if I wanted to write these answers and include all of the answers, and the infinite number of answers, what I'm going to do is I'm going to take the first answer, which is 30, and I'm going to add the period that is the period of sine, and I'm going to add that n number of times, where n is any integer, from 0 to infinity or 0 to negative infinity. So this would be the first general solution. The second one would be 150 plus 360n. Those would be like my two answers in degrees. If I wanted to write the same two answers in radians, I'm going to write pi over 6 plus 2 pi, because that's my period n, 2 pi n, or 5 pi over 6 plus 2 pi n. There are my two general solutions. Okay? Let's do one here. So we want to solve this for x. Let's do this right now as the periodic solution 0 to 360 in degrees. First thing I'm going to do is I'm going to solve for the trigonometric function by subtracting 1 from both sides. So now I have root 2 sine x is equal to neg 1, and I'm going to divide both sides by root 2. I was getting ahead of myself there. Divide both sides by root 2. So now I have sine x is equal to negative 1 over root 2, which of course is equal to negative root 2 over 2. Ding, 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 ding. I'm hoping you recognize that as one of our special right triangles. I have a negative sign, which is third and fourth quadrants. Okay, so now I know that those are the 45-degree angles in the third and fourth quadrants. So the first one is 225. The second one is 315. And again, if you think about that, that's because I need to get to the 45-degree angle in the third quadrant. That's 180. That would be 225. I also need to get to the fourth quadrant angle. That is the 45. So that would be that one, which is going to be 90, 180, 270 plus the 45 again, which is 315. Okay, so there are my two answers. In degrees, if I wanted to write the general solutions of this, I would just add a 360n to both of them. And there are my general solutions in degrees. Okay? Let's try this one. This one's a little bit different. We'll do this one in radians this time. I'm going to look to factor. I see that I can do some factoring right now. I'm going to get a new color. Boy. I'm going to factor a cosine x from both terms there on the left-hand side. So I have cosine x times cosine x minus 1 is equal to 0. Now it's just like I'm solving a quadratic equation. I'm going to set both of these factors to 0. So therefore, cosine x is equal to 0, or cosine x is equal to 1, right? Because cosine x, let me write that out for you. It's getting ahead of myself. Cosine x minus 1 is equal to 0, which means now if I add the 1 to both sides, cos x is equal to 1. Well, for what angles is cosine x 0? 0 to 360, cosine is 0, and again, you notice that it's at the 90 or the 270, which of course is pi over 2 or 3 pi over 2. When is cosine x equal to 1? It's only at one spot, 0 to 360. It's at 0, and at 360 again, but we don't repeat it. We go 0 to 360, including 0, not including 360. We don't need to include both. So we just say cosine x is 0, is 1 at 0. So my answers are pi over 2, 3 pi over 2, and 0. Those are my three answers. There are three answers here, and if I wanted to write these as a general solution, I'm just going to add a 2 pi n to both of them. To both of them, to all three of them. All right, let's try another one. See how many we want to do here. Okay, this next one here, again, I'm probably going to look to factor at some point, so I'm going to move all my terms to one side. So I'm going to have secant x, cosecant x, times cosecant x, minus 2 cosecant x equal to 0. Okay, I'm going to factor out my cosecant x from both of these terms. So I'm going to have a cosecant x times secant x minus 2 is equal to 0. So now cosecant x is equal to 0, or secant x is equal to 2. And again, I'm just going to set that equal to 0 and solve for secant. Cosecant x will never be 0, and we know that by thinking about what the graph of cosecant looks like. and we can never have, there's no value for sine, which makes 1 over sine equal to 0, because we have a 1 up top. Okay, so this answer right here is junk. It leads to nothing. That factor did not help us. The other factor here we're looking at is secant x is 2. Well, if secant x is 2, that means that cosine x is equal to 1/2. If cosine x is equal to 1/2, I'm in the positive quadrants for cosine, which is the first and the fourth. Cosine x is equal to 1/2 when x is equal to 60. So doing this in radians now, in the first quadrant, that's going to be pi over 3. In the fourth quadrant, that's going to be, don't tell me here, 5 pi, 4 pi over 3. Okay, and those would be my periodic solution, 0 to 2 pi. If I wanted to write the general solution, I would just write 2 pi n at the end of both of them. Okay, so again, this is 60, and this is going to be 300. I did that right? It is 5 pi. 5 pi over 3. Okay? Okay, I know I skipped a couple of these things here, but let's skip ahead to this example right now, and this will be the last one. I think we've done enough. We'll do the rest in class. We have secant 4x is equal to 2. Let's just think about this for a minute. I'm going to take the reciprocal of both of these right now, just make my life easier, because I would much rather work with a cosine. So I have cosine of 4x is equal to the reciprocal of 2, which of course is 1/2. Now, just think about the cosine curve for a minute. If I want to get the periodic solution, 0 to 2 pi, or 0 to 360, and we'll do both. Okay, I know that typically my cosine curve in one period looks something like this. But now what's going to happen when I have this 4? I know my whole curve gets squished by a factor of 4, so I'm actually going to have 4, that was only 3, 4 waves. I'm going to have a lot more answers. 1, 2, 3, I would have to throw in one more wave. I would have 4 curves in the same amount of space. So, that being said, let's get rid of that. We're going to solve this for cosine 4x. So we have that done right now. So I know that right now, if this were x, we know that this would be the 60 and the 300. We just did this one a couple problems ago. Okay, so now I know that 4x is equal to 60, the first quadrant angle, and 4x is also equal to 300 in the fourth quadrant. Now here's the issue. My period is now 90. Okay, because I took the 360 and I divided by 4. So I'm going to take my 4x plus 60 and I'm going to actually write this in general form. Okay, so I have 4x plus 60. I just need to move this guy over. Okay, plus 360n. And now to solve this for x, I am going to divide both sides by 4. When I do that now, I can see that I have x is equal to 60 divided by 4, which is 15, plus 90n. So in other words, I know I'm going to count by 90s until I get to up to above 360. So my answers here are 15 plus 90, which is 105, 105 plus 90, which is 195, and 195 plus 90 is 285. I'm going to get 4 angles as opposed to just 1. I'm going to do the exact same thing right here with the 4x is equal to 300. So I'm going to write that in general form. So I have 4x is equal to 300 plus 360n. Divide both sides by 4. That gives me now x is equal to 300 divided by 4, which is 75. And then I'm going to just keep adding 90. So that's also 165. 165 plus 90 is 255. And 255 plus 90 is 345. So I actually have now 8 answers, which makes sense. It's twice as, or 4 times as many as 2. I have 8 answers for x, 0 to 360. 15, 105, 195, 285, 75, 165, 255, and 345. If I wanted to do that in radians, I would know that I would have 4x was equal to my 60, which is pi over 3 plus 2 pi n. I now need to divide both sides by 4. Okay? So I get x, pi over 3 divided by 4 is going to be pi over 12. And now I need to keep adding. 2 pi n over 4 is half a pi n. So I need to keep adding 6/12 pi. So this is going to be, 1/12 pi plus a half a pi is 7 pi over 12. 7 pi over 12 plus 6 pi over 12 is 13 pi over 12. And 13 pi over 12 plus 6 pi over 12 is 19 pi over 12. If I take my 300, which we said was 5 pi over 3, so 4x is equal to 5 pi over 3 plus 2 pi n. I'm going to divide both sides by 4. X is equal to 5 pi over 3 divided by 4 is 5 pi over 12. And I'm going to add my 6/12 pi once again, which is 1/2 pi. So that's, my next answer is going to be 11 pi over 12. I'm going to have 17 pi over 12. And lastly, 23 pi over 12. And once again, you can see now I have 4 answers right here. And I have 4 answers right here. Okay? There we go.